Assalamu alaikum guys, so welcome back. Today we are gonna do integration. Alright, we are gonna start off with the basic integration first, and then we are gonna progressively move on to the more advanced integration of year 2. Alright, now the basic integration first question is right over here. Integral of 3x4 minus 3x to the power 4 minus 4 over 2x cubed. This is very simple, but the very first thing you need to do is simplify this further. So the 3x4 minus 4 can both be written separately, divided by 2x cubed. Once you do that, simplify them further. So this is going to become 3 over 2 x minus 2x to the power of negative 3. The integral sign stays the same. Now just integrate it. So this is going to become x to the power of 1 was this previous power, but add 1 to it and divide this by the new number. 3 over 2 stays as it is, minus x to the power of negative 3 plus 2 plus 1 divided by the new number. So the new number is negative 2, right? Negative 3 plus 1 is negative 2 into 2. And then a constant. Simplify this further, so it's going to become 3 over 4 x squared plus x to the power of negative 2 plus c. This is our final result of the integration. Done with the first question. Let's move on to the second question. Integrate this formula right over here, giving your answer in the simplest form. So for this, again, you need to simplify it. This is 8x cubed, it's fine. But the other one is negative 3 over 2 into x to the power of negative 1 over 2 plus 5. I've simplified it. Then integrate it further. So this is going to become x to the power of 4 divided by 4. 8 stays as it is. Minus x to the power of negative half added to 1, which becomes plus half. This has to be divided by 1 over 2 as well. And 3 over 2 stay in their place. And 5x plus c. Simplify it further. 2x4, half and 2 cancels out. So negative 3 under root x plus 5x plus c. That's your answer. Let's move on to question 3 now. The height of a plant t years after it was first measured is modeled by this equation right here. Using this model, find the height of the plant when it was first measured. When it was first measured would mean the time is 0, right? And e to the power of 0 is 1. So the height becomes 2.3 minus 1.7 e to the power of negative 0.2 into the time is 0. Now e to the power of 0 is 1. So this will become 2.3 minus 1.7. Which equals 0.6. meters. That's the height. Then part B. Show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimeters per year. So after 4 years have passed, it was growing at this rate. Now, what happens after 4 years? What would be the height of the plant? height after 4 years becomes 1.54, 536 meters. That's the height after 4 years. We need to find out the speed at which it was growing. So we can differentiate this dh over dt. That will give us the speed, right? It's a change in height over change in time 4 years later. So this is simply going to become e to the power of negative 0.2t, and negative 0.2 will be multiplied by 1.7. So that's going to become 0.34. And now if the time is 4 years, just put it in here, and what do we get? We get the same answer. Zero point 153 meters per second. But actually, the first part was not required over here. You can remove that out. It's the second part that's required. They're asking us the rate at which it increases, it grows. So this can be converted into centimeters per second by just multiplying it by 10. So 15.3 centimeters per second. Sorry, not per second, per year. So 15.3 centimeters per year is the rate at which it grows after 4 years. Okay? According to the model, there is a limit to the height to which this plant can grow. Deduce the value of this limit. Okay, limit means there's a maximum value of h, right? How can we get the maximum value of h? Maximum means the maximum turning point, right? The maximum stationary point. And for something to reach a maximum, the gradient has to become equal to 0, right? So this dh over dt has to become 0. But wait, if you just look at this formula, we have a number from which something is being subtracted, 2.3. Maximum should be 2.3. Because as time passes by, the 2.3 is becoming smaller and smaller, right? Or larger and larger. This number is becoming larger and larger. So maximum should be 2.3, because in this formula, you are subtracting the 1.7 e to the power of negative 0.2t from the 2.3. That's your maximum height. Okay. Alright, that's it for this video. We'll continue in the next video.